Section 4.2. In this section, we will simplify radical expressions containing variables. Now, in the last section, we simplified radical expressions that just contain numbers. So, before I move to the next slide, I've inserted a blank slide here because I feel like if I just read the next slide, which basically gives you directions on how to find the square root of a variable that has an exponent on it, you may not exactly understand it, and that perhaps you'll understand it better if I do a little more explaining. So that's why I've added a slide here. So we know that when we square something, we're multiplying it by itself. So we know that if I multiply x times x, I'm squaring x, it's equal to x squared. Because recall, you remember we're adding our exponents. So x to the first times x to the first is x squared. And I'm just going to continue this so that we can see it. We're trying to find a pattern. X squared multiplied by itself, so we're squaring x squared is equal to x to the fourth. We know that x cubed squared is equal to x to the sixth. We know that x fourth squared is equal to x to the eighth. And I'll just do a couple more here. We know that x to the fifth squared is equal to x to the 10th. And we know that x to the sixth squared is equal to x to the 12th. Okay? So now let's think about taking the square root of these. We know that when we take the square root of something, we're trying to find, for instance, if we took, recall in the last section, if we are trying to find the square root of 16, for instance, I'll just put this up here, we know that's equal to 4 because 4 squared is equal to 16, or 4 times 4 is equal to 16. Okay, so if I say if I ask what is the square root of x squared, well, that's going to be equal to x, or x to the first, right? Because x to the first times x to the first is x to the second. If we're trying to find the square root of x to the fourth, well, that's going to be x squared, because x squared multiplied by itself is x to the fourth. The square root of x to the sixth is equal to x cubed, because x cubed multiplied by x cubed is x to the sixth. The square root of x to the eighth will be x to the fourth, because x fourth squared is x to the eighth. The square root of x to the 10th is x to the fifth. And the square root of x to the 12th will be x to the sixth, because x to the sixth multiplied by x to the sixth is x to the 12th. Okay? So what I'm going to ask you here is, well, first of all, notice that all of these here, let me draw an arrow, these were all perfect squares. And notice if you have a variable with an exponent on it, and it's a perfect square, notice that if it's a perfect square, its exponent will be even. Okay? If it's a perfect square, its exponent will be even. Now, over here, I've taken the square root of x squared and gotten x, the square root of x to the fourth and gotten x squared, and so on. And so what I'm asking you now is, if you're trying to take the square root of a perfect square, if you're trying to take the square root of a variable that has an even exponent, how do you do that? And what you may notice is, in this pattern, is that if you divide the exponent by 2, 2 divided by 2 is 1. 4 divided by 2 gives you this 2 on x squared. 6 divided by 2 is 3. 8 divided by 2 is 4. 10 divided by 2 is 5. 12 divided by 2 is 6. So if we want to take the square root of a variable that has an even exponent, we're going to divide the exponent by 2, and remove the radical sign. Notice, for instance, the square root of x to the 12th is equal to x to the 6th. Notice we had to remove the radical sign once we took the square root. Okay, the square root of x to the 12th is x to the 6th. So that will help you understand the writing that I have on the next page. If a represents a non-negative quantity and n is an even integer, then the square root of a to the n is equal to a to the n divided by 2. A variable or the product of variables written in exponential form is a perfect square when each exponent is an even number, which I showed you on the previous slide. So if a variable has an even exponent, we know it's a perfect square. And to find the square root of a variable, which is a perfect square, we're just going to remove the radical and divide the exponent by 2. So this sums it up right here, okay? All right, so let's practice some of these. So to take the square root of x squared, once again, divide the exponent by 2. 2 divided by 2 is 1, so we get x to the first, and we remove the radical. But we're not going to write that as x to the first. We're just going to write it as x. The square root of y to the 16th, 16 divided by 2. Please do not be tempted to say it's y to the 4th. Okay, the square root of 16 is 4, but we're not finding the square root of 16. We're finding the square root of y to the 16th, which will be equal to y to the 8th, because y to the 8th squared is y to the 16th. To find the square root of x to the 4th, y to the 6th, we divide each of these exponents by 2. So in this case, we will get x squared y to the 3rd. Notice the radical sign is removed. The square root of 64 is 8. The square root of x to the 64th is x to the 32nd. Okay, notice we took this 8 times 8 is 64. X to the 32nd multiplied by x to the 32nd is x to the 64th. The square root of 49 is 7. The square root of a to the 4th is a squared. The square root of b to the 8th is b to the 4th. The square root of 100 is 10. The square root of b to the 100th is b to the 50th. All right, at this point in the game, these ones get a little more complicated because notice the number 24 isn't a perfect square. So these next coming problems, we're going to have to put together what we learned in the previous section as well in 4.1. Because 24 is not a perfect square, let's go ahead and do a factor tree. 4 times 6 is 24. 2 times 2 is 4. 2 times 3 is 6. And recall we're looking for pairs, okay? So there's a pair of 2's. And then we have a leftover 2 and a leftover 3, 4 and 6. So remember we're using that multiplication property of radicals. And so we're going to rewrite radical 24 as radical 4 multiplied by radical 6. And then we'll also take the radical of x to the 24th. Okay, and I like to split things up. So what you'll notice is when I'm simplifying these, when I rewrite the problem, first of all, everything will still have a radical sign on. I split everything up first, and then afterwards I start doing my simplifying. The square root of 4 is 2. Make sure the radical sign is taken off. Square root 6 is irrational, so it stays the same. Take the square root of x to the 24th by dividing it by 24 divided by 2, that's equal to x to the 12th. Notice the radical sign is gone. So now everything that is simplified, which is the 2 and the x to the 12th, comes up front, and the radical 6 stays behind. So we can read that as 2x to the 12th times the square root of 6. All right, so let's do a factor tree for 48. We have 2 and 24, 4 and 6, 2 and 2, and a 2 and 3. So I have 2 pairs of 2s, so a 4 and a 4 and a leftover 3. Okay, so when I split up the 48, I'm going to have radical 4 times radical 4 multiplied by radical 3, and then I'll have to take the square root of each of these things too. The square root of 4 is 2. The square root of 4 is 2. Square root 3 stays the same. The square root of x squared, 2 divided by 2 is 1, is x to the first. The square root of y to the 6th is y to the 3rd. The square root of z to the 10th is z to the 5th. Notice the radical signs are gone on those things that you divided. So now look at everything that no longer has a radical sign, because that's going to come up front. 2 multiplied by 2 is 4. Then we'll put x, y to the 3rd, z to the 5th, square roots of 3. 4x y cubed z to the 5th square roots of 3. How was that? Okay, we have quite a few more to do, so let's roll on. Okay. All right, we took the square roots of variables that have even exponents by dividing them by 2. Okay. Now, in order to take the square root of variables that have odd exponents, we're going to have to use this multiplication property of radicals. Okay. In order to simplify a radical expression containing variables with odd exponents, one must use the multiplication property of radicals. So we're going to have to split those up. And let me just show you how we're going to do those. Okay. So look at problem I on page 242. And notice we're taking the square root of a to the 15th. And obviously 2 does not evenly divide into 15. So this is what you're going to do when you have an odd exponent. You're going to take one away from the 15. You're going to rewrite radical a to the 15th as the product of two radicals. You're going to write it as radical a to the 14th times radical a to the 1st, since a to the 14th multiplied by a to the 1st is a to the 15th. Then you'll take the square root of the a to the 14th, because it's now even. That will equal a to the 7th. The radical sign you can take off. And then the square root a cannot be simplified anymore. So you'll just get a to the 7th times the square root of a. So when you're done simplifying these radicals, you should never have a variable underneath a radical that has an exponent greater than 1. Because if you do, then you need to simplify it some more. All right, look at J. Notice both of these have odd exponents, so we can't divide them by 2. So look at the x cubed. Take 1 away from x cubed. We'll put an x squared there. The leftover one we'll put by itself. We're going to split up the y as well. Take 1 away from the y to the 15th. We'll put a y 14th there. The one we took away we'll put by itself under a radical. We'll take the square root of x squared. 2 divided by 2. Whoops. 2 divided by 2 is 1. That gives me an x to the 1st. Square root x just drops down. The square root of y to the 14th is y to the 7th. And square root y just drops down. You can't take the square root of that. Xy to the 7th they no longer have radicals. So we get xy to the 7th, and then the x and y that are still underneath radicals, you'll just put those back underneath one radical behind the xy to the 7th. So you'll get xy to the 7th times the square root of xy. Or you could read that as xy to the 7th square roots of xy. All right, let's take the square root of a to the 3rd, b to the 11th. These are odd exponents as well. They're not perfect squares. So we're going to be splitting the a up. We'll take one away. We'll write an a squared. There's the leftover a. We'll take one away from the b to the 11th. We'll have a b to the 10th. And there's the leftover b right there. The square root of a squared is a. The radical a will drop down. The square root of b to the 10th is b to the 5th. And the radical b will drop down. The b to the 5th we will write up front. The square root ab will shove back underneath one radical. So we get ab to the 5th times the square root of ab. Now, on the next problem, 60, we'll do a factor tree for it. Please do not be tempted to say that the square root of x to the 9th is x to the 3rd. Remember, we need to divide the exponent by 2, but since it's not a perfect square, we're going to have to split it up. So I'm going to do a factor tree for 60. 6 and 10. The 6 goes to 2 and 3. The 10 goes to 2 and 5. I have a pair of 2's. I have a leftover 3 and a leftover 5. So 4 times 15. So I have a radical 4 times radical 15, which will equal the radical 60. I'm going to take 1 away from the x to the 9th. That's a radical x to the 8th times radical x to the 1st. The square root of 4 is 2. Radical 15 is irrational. The square root of x to the 8th is x to the 4th. Drop down square root x. The 2 and the x to the 4th were simplified. We pull those out front. Times the square root of 15 and x. Those irrational parts shove back underneath one radical sign. All right. The reason why these ones are given is to kind of like so that you don't fall into these traps, because the square root of 49 is a perfect square. That's 7. So we'll be able to take the square root of that. Let me just put it under a radical for a second. However, the square root of n to the 49th, you're going to take one away and write that as n to the 48th times the square root of n to the 1st, correct? The square root of 49 is 7. The square root of n to the 48th is n to the 24th times the square root of n. So you get 7n to the 24th square roots of n. The next is a similar example. We'll take the square root of 121 in a second. We don't need to split it up. It's a perfect square. To take the square root of 121, though, we'll have to take one away. We'll write that as x to the 120th times square root x to the 1st. The square root of 121 is 11. The square root of x to the 120th is x to the 60th square root x. So we get 11x to the 60th times the square root of x. All right, the remaining 4 we're going to have to do factor trees for. So 18. We have a 2 and a 9. The 9 goes to 3 and 3. So you can see your pair is your 3 and your 3. You may have stopped there already. That's a 9 with a leftover 2. So we have a radical 9 times radical 2. I'm going to have to split up the x. I'm going to have an x to the 4th and a radical x. I'm going to have a y to the 6th and a radical y. The square root of 9 is 3. Radical 2 drops down. The square root of x to the fourth is x squared. Radical x drops down. The square root of y to the sixth is y to the third, and radical y drops down. So whatever doesn't have a radical, we move up front. That would be a 3x squared y to the third. And then we'll shove the 2xy back underneath one radical. So 3x squared y cubed square roots of 2xy. When we do a factor tree for 20, 4 times 5 is 20, 2 times 2 is 4. We have a pair of 2's. That's a perfect square of 4. We have a leftover 5. Now this 4 is just dropping down. Now I'm splitting up the 20. Radical 4 times radical 5 is the radical 20. The square root a to the fourth, I don't have to do anything with that. I can divide it by 2. The b to the 13th, I'm going to take 1 away. And the leftover 1 I'll put by itself. And now I'm ready to simplify. So I'll drop this 4 down. The square root of 4 is 2. Radical 5 is irrational. It drops down. The square root of a to the fourth is a squared. Be sure to take the radical sign off. The square root of b to the 12th is b to the 6th. And these are all multiplied together, guys. I'm just not putting dots in between them all. And then times radical b. Because when we shove them back all together at the end, we don't put multiplication dots in between them. But they are all being multiplied together. Okay, so we have 4 times 2 is 8. I have an a squared b to the 6th square roots of 5b. 8a squared b to the 6th times the square root of 5b. 2 more. Alright, so in Q the 3x will drop down. I'll do a factor tree for 12. Now at some point, guys, I mean, when you break the 4 down to 2 and 2, you can see 4 is your perfect square that you're going to take the square root of. You have a pair of 2's, which is a 4, and a leftover 3. Okay, so you'll have radical 4 times radical 3. We're going to square root x squared. We don't have to split up. You're going to have to split up the y to the 5th. I'm running out of room here. And there's a leftover y there. I'm just going to try to get my eraser going, but okay. So there's my y. Okay, so now I'm ready to take square roots. So this 3x drops down. I'm going to have 3x, and that's an x to the first, times the square root of 4 is 2, times a radical 3. The square root of x squared is x. The square root of y to the fourth is y squared. And I have a radical y. Okay, so I can multiply 3 times 2 and get 6. X times x is x squared. I'm pulling my y cubed up right here. And then I have, underneath radicals, I have the square root 3 and a square root y. So I'm putting that back underneath one radical. So I have 6x squared y cubed times the square root of 3y. And then the final problem that I'll be doing with you, if you go to do a factor tree for 98, you'll notice it breaks down to 49 and 2. And 49 is a perfect square because 7 times 7 is 49. So that's how I'm going to split up the 98. So the 4a drops down. I'm going to have radical 49 times radical 2. 7 is odd, so I need to take one away. I'll rewrite that as radical a6 times radical a, and I do not have to split up the b to the 12th. So I'm going to have 4a multiplied by the square root of 49, which is 7, multiplied by radical 2. The square root of a to the 6th is a cubed, multiplied by radical a. The square root of b to the 12th is b to the 6th. Okay, now this is an a to the 1st here. Okay, so we have a 4 multiplied by 7, which is a 28. I have an a to the 1st multiplied by a to the 3rd, which is a to the 4th. I have a b to the 6th, and then times the square root of 2a left under a radical. So 28, a to the 4th, b to the 6th times the square root of 2a. So this concludes lesson 4.2.